Hi guys, Audrey here. So now we're just going to do a really quick example of the limit comparison test. Okay, as usual, we want to start off with a test for divergence. So we're all limit n goes to infinity 8n squared plus n plus 7 over the cubed root of n to the 7th plus 5 n cubed plus n squared minus 3, and we can take the big stuff. So we're just gonna take the 8n squared and the cubed root of n to the 7th that shows up right there to be like, this is equal to the limit as n approaches infinity, 8n squared over n to the 7 over 3 equals the limit as n approaches infinity of 8 over n to the 7 over 3 minus 2, which is 6 over 3, so that's n to the 1/3, which goes to 0, and the test for divergence fails. Now we have to pick which test to use. So what we see here is a bunch of things with n to the power. We also saw that when we did the test for divergence, we were able to take the big stuff and end up with something that looked quite a bit like a p-series. So that's what we're going to go with here. We're going to say, okay, so comparison is a good idea. We have all those n's to the powers. So we are going to try comparison. And when we're trying comparison, we want to bound this thing. So I'm saying 8n squared plus n plus 7 over the cubed root of all of that stuff again. And really the technique that we used there when we applied the test for divergence of just taking the big stuff is how we're going to find our series to compare to. We already saw that that gives us 8 over n to the 1/3. So we would want to compare to the sum of n equals 2 to infinity. I'm going to keep that 2 the same as the original 2 in the original thing that we had up there, of 8 over n to the 1/3. Now this is a p-series. My p is equal to 1/3, which is less than 1, which means that this thing we know diverges. So then what I would want to be true is that my original thing, 8n squared plus n plus 7 over the cubed root of all of that massive thing there, n to the 7th plus 5n cubed. I should have done something shorter so I don't have to write this every time. I want this to be bigger than 8 over n to the 1/3. Well, I don't know about you guys, but that does not look like a pleasant inequality to solve. To figure out if it's true, for what n's it's true. Yuck, I don't want to do it. So remember we said when the inequality is not true, we can just immediately move on to limit comparison, or when the inequality is gross and we're all like, I don't want to do it, we can also move on to limit comparison. So we're actually going to write, yuck, try limit comparison test. Okay, so remember the limit comparison test would tell me now we're going to do the limit as n approaches infinity of the original thing. Again, I am regretting putting so many extra terms in the original thing. Cubed root n to the 7th plus 5n cubed plus n squared minus 3. And then I'm taking the series I'm comparing to and I'm dividing by it. Division by a fraction means I'm flipping that fraction over. So I'll have n to the 1/3 over 8 here. Now, I'm going to get infinity over infinity when I plug in that indeterminate form. So I'm just going to take the big stuff. And remember, taking the big stuff requires us to take something from every single factor. So what I end up with is the limit as n approaches infinity of 8n squared times n to the 1/3 over 8n to the 7 over 3, which is equal to the limit as n approaches infinity of 8n, that's to the 7 over 3, over 8n to the 7 over 3. And those n to the 7 over 3's cancel out, those 8's cancel out, and we get that this is just 1, which is indeed bigger than 0 and finite. It is not equal to 0, and it is not infinite. So what this tells me is both series are doing the same thing. And what this tells me is that therefore, since we know that 8 over into the 1/3, that series diverges because it's a p series, my original series, n equals 1 to infinity, I'm sorry, it was a 2 down there. We're just going to call it a to the n, diverges by the limit comparison test. And that is all. That's all, guys. Bye.